China has earned the nickname Infrastructure Maniac. This nickname is not derogatory, it reflects foreigners' astonishment at the speed of China's development. In today's video we will bring you mighty Chinese construction technology whose engineering shocks America's engineers to bone. But before we dive in, we kindly ask you to show your support by liking this video and subscribing to Machine EY. We value your thoughts and invite you to share your opinions on these remarkable construction technologies in the comments below. Without further ado, let's embark on an extraordinary journey on Hong Kong Beipanjiang Bridge. On this planet, there exists a type of engineering marvel that inspires awe and pride in equal measure: bridges. In this realm, China is redefining the meaning of bridges with its technology, perseverance, and innovation. From cable-stayed bridges spanning deep mountain valleys to super projects crossing vast oceans, China, often called the infrastructure giant, has claimed the pinnacle of global bridge engineering. Today, let's explore just how incredible Chinese bridges are and uncover the secrets behind their creation. Let's start with one of the most renowned bridges in the world, the Hong Kong Beipanjiang Bridge. As its name suggests, this bridge connects Hong Kong, Zhuhai, and Mao, spanning the Ling-Dingyang waters. It stretches 55 kilometers, making it the longest sea-crossing bridge in the world. However, it is more than just a bridge, it is a bridge-island tunnel combination project. To allow the bridge to cross busy shipping lanes, engineers constructed a 6.7 kilometers long underwater immersed tunnel. Each segment of the tunnel weighs 80,000 tons, equivalent to the weight of an aircraft CFT carrier. How challenging is it to install an immersed tunnel? For instance, the alignment tolerance during the connection of each tunnel segment cannot exceed 2 centimeters. Yet in deep waters where currents, silt, and pressure are major challenges, achieving such precision seems nearly impossible. But Chinese engineers turned the impossible into reality with their cutting-edge expertise. After relentless efforts, a world-shocking underwater tunnel was successfully completed. This raises a question: with the sea filled with water, how did Chinese engineers manage to construct this underwater marvel? Let's dive deeper into the process. There are 4 common methods for constructing underwater tunnels: the drill and blast method, which uses explosives, the TBM and shield tunneling methods, suitable for hard rock and soft soil respectively, and the immersed tube method, which involves lowering pre-made pipe sections onto the seabed and connecting them. The drill and blast method, also known as the mining method, involves using explosives to carve out a section, removing the rubble, and lining the tunnel walls. This cycle repeats until the tunnel is complete. Since blasting can disrupt surrounding rock layers, this method is often used in stable geological conditions. When fractures and rock formations cause water seepage, engineers must inject grout to create a watertight barrier for stability. China's first underwater tunnel, the Xiamen Tunnel, was built using this method. TBM and shield tunneling methods involve large drilling machines. TBMs are used for hard rock environments, while shield machines excel in soft soil layers and feature waterproof capabilities. These machines simultaneously excavate and assemble concrete segments to support surrounding rock, preventing tunnel collapses. The shield tunneling method is particularly versatile due to its full mechanization. Lastly, the immersed tube method involves submerging prefabricated tunnel segments and connecting them underwater. Waterproofing the connections is critical. The Hong Kong Beipanjiang Bridge's tunnel was built using this method. Constructing an immersed tunnel is a complex and precise process, akin to crafting a masterpiece. The first step is building a dry dock similar to a shipyard. Engineers excavate a massive rectangular water tank near the tunnel site and use techniques like slope excavation and diaphragm walls to ensure level base and watertight conditions. This creates a solid foundation for fabricating the tunnel segments. Within the dry dock, steel reinforcement cages form the skeleton of the tunnel segments. Concrete is then poured into molds to create the segment walls. After curing, engineers maintain optimal concrete quality using ultrasonic mist cooling internally and geotextile blankets externally for moisture retention. Outfitting the tunnel segments is a critical phase, including installing ballast water systems, pipelines, and monitoring systems. The segment's exterior surfaces are coated with polyurethane to ensure waterproofing. The ends of the segments, crucial for connection, are equipped with steel bulkheads, waterproof gaskets, and sealed doors to maintain integrity during installation. Once outfitting is complete, the dry dock is flooded and the segments undergo rigorous testing to ensure their readiness for transport and installation. The foundation trench for the immersed tunnel must be meticulously excavated. Large dredgers handle rough excavation, smaller dredgers perform precision digging and leveling, and vessels finalize the surface. The riverbed's flatness error must not exceed 4 centimeters to enable precise placement of the segments. Next comes the most exciting phase, segment transport and installation. Tugboats and anchor cables position the segments at the designated location, guided by BU navigation and digital monitoring systems for millimeter-level accuracy. During installation, engineers flood the segments to gently lower them into the trench and align them for connection. This phase demands exceptional technical expertise and teamwork. After installation, the segments are reinforced with gravel backfill, geotextiles, and anti-scour stone cages to ensure structural safety and long-term stability. Finally, the interior of the tunnel is equipped with electrical systems, fire prevention setups, and decorative finishes. High-quality roadways are laid to ensure the tunnel meets transportation and safety standards. From dry dock construction to segment alignment, every step of the immersed tunnel's creation exemplifies engineering precision. The Hong Kong Jim Mao Bridge's tunnel not only conquered nature's barriers but also showcased Chinese engineers' ability to push the boundaries of innovation. Now let's travel to the Beipanjiang River Bridge in southwestern China to visit the Beipanjiang Bridge, a ladder to the heavens suspended in the clouds. The bridge stretches 1,341 m in length and soars 565 m above the valley floor, making it one of the world's highest bridges. Standing on it feels like the entire world lies beneath your feet. During construction, workers had to anchor foundations into steep cliffs and erect the structure layer by layer, battling fierce winds and thick fog. They overcame life-threatening challenges to turn an insurmountable chasm into a vital connection. When China announced its plan to invest 1 billion yuan in the construction of the Beipanjiang River Bridge, American experts predicted it would take China 300 years to complete this monumental project. To everyone's amazement, Chinese engineers defied expectations and completed the colossal undertaking at an unimaginable speed, leaving the once mocking American experts silenced. Oh God, please no, no. In reality, it took only 3 years for China to successfully finish the Beipanjiang River Bridge. One can only wonder how long it might have taken if the project were undertaken by the United States. Feel free to share your thoughts in the comments. The rugged terrain and extremely poor transportation conditions in the Gu region had a profound negative impact on the local population's economic development. Therefore, in 2013 China decided to construct a world record-breaking bridge at the intersection of Yunnan and Gu provinces to completely transform Gu's harsh transportation environment. However, this plan faced mockery from Western bridge expert Smith. With a height of 565 m, equivalent to 200 floors, surpassing even the tallest U.S. structure, the World Trade Center at 412 m, foreign media rushed to report on the seemingly impossible project. Smith, after inspecting the Beipanjiang Grand Canyon, asserted that even with American technology it would take 300 years to complete, suggesting China would need at least 3,000 years. Despite the ridicule, Chinese engineers courageously faced the challenge, determined to make Beipanjiang the world's highest bridge. However, the engineering team was undeterred by external mockery and dedicated themselves wholeheartedly to the construction. Situated in a canyon with a main bridge length of 1,341 m, traditional bridge pier construction in the canyon was impossible. Considering wind risks, the construction team opted for cable-stayed bridge technology. During construction, Chinese engineers innovatively employed longitudinal movement and hanging assembly techniques for the first time, lifting and assembling the 12 m, approximately 160-ton steel trusses in midair. Precision alignment of 27 mm diameter bolts was essential. Despite the fierce canyon winds, Chinese engineers overcame every challenge, demonstrating their ability to tackle any obstacle. To address challenges like impassable rivers for traditional ship transport of cut-off beams, engineers adopted new methods. Beams were disassembled into smaller pieces, transported to the site by trucks, and assembled like building blocks. This accelerated the installation process, shortened the construction period, and reduced damage to the bridge piers. Additionally, for the steel cables lifting the bridge deck, China's engineering team used one of the strongest materials with a compressive strength exceeding 1860 MPa and a dynamic load yield strength reaching 250 MPa. This material greatly ensured the stability of the bridge under strong winds and water vapor erosion, guaranteeing the project's safety. We see the deck of the Beipanjiang River Grand Bridge connected to its tower with steel cables spanning 250 feet, enough to stretch from New York City to Washington, D.C. To construct this unprecedented architectural marvel, Chinese engineers had to tackle numerous challenging engineering feats. The bridge spans the isolated depths of the Gua Grand Canyon, making it an epic engineering endeavor. Between two iconic towers, it stretches over a mile-long deck supported by 250-foot steel cable. It carries an incredible 22,000 tons of weight. This bridge can arguably be deemed the most colossal bridge structure on this planet. Through this project, China not only showcased its strength, providing effective support for poverty alleviation projects in Beipanjiang, but also defeated foreign experts who once mocked China. In fact, even the United States, with its arrogant statements about China, couldn't guarantee the completion of the Beipanjiang River Bridge. This bridge stands as a milestone in China's infrastructure development, serving as an irreplaceable transportation hub. In 2016, with a cost of 1 billion yuan and a construction time of 3 years, the Beipanjiang River Bridge, standing at a height of 565 m, would have taken at least 3,000 years to complete, according to its critics. Located in the central part of the Yunnan-Asia Plateau, overcoming steep terrain and complex geology, the Beipanjiang River Bridge has shortened the travel time between Yang and Gu to just 1 hour. Bringing new hope to this land, it became a source of pride in China's bridge construction. The completion of the Beipanjiang River Bridge signifies another miracle in the history of global engineering. Additionally, the Hebei Bridge, the world's third longest sea bridge, links Ningbo and Shanghai, spanning 36 kilometers. Built in a region notorious for its treacherous tidal conditions, the bridge overcame what was once considered a no-go zone for construction. It has since cut travel time between the two cities and spurred economic growth in the Yangtze River Delta region. China's dominance in bridge engineering stems from its advanced technology. For instance, China's steel structures are world-class. The Hong Kong-Jima Bridge alone used over 420,000 tons of steel, enough to build 60 Eiffel Towers. This steel is not only incredibly strong but also resistant to marine corrosion, ensuring a lifespan of 120 years. China has also established a fully integrated bridge construction industry from design to manufacturing. During the construction of the Hong Kong-Jima Bridge, all lifting equipment, transport vessels, and prefabricated components were made in China. This self-reliance reduced costs and significantly boosted efficiency. China's diverse terrain, including plateaus, mountains, plains, and seas, serves as a stage for engineers to innovate. From the Lost Plateau to the Tibetan Plateau, and from the Pearl River Delta to the Bohai Bay, each bridge is a testament to ingenuity tailored to local conditions. The significance of bridges goes beyond connecting two sides. They reshape transportation networks. The Hong Kong-Zhuhai Bridge reduced travel time between Hong Kong and Zhuhai from 3 hours to 30 minutes, strengthening regional ties and injecting new vitality into the Pearl River Delta's economy. Bridges also transform entire regions. For example, Guan's Pingnan Third Bridge, one of the world's largest arch bridges, has improved travel for local residents while boosting tourism and logistics industries. China's bridge-building prowess is making waves internationally. The Padma Bridge in Bangladesh, built with Chinese expertise, is hailed as a lifeline for South Asia's economy, solidifying China's reputation in global infrastructure. Looking ahead, China plans to construct more deep-sea bridges connecting distant islands to the mainland. This not only presents technological challenges but also reflects a vision for global connectivity. Artificial intelligence and IoT technologies are also being integrated into bridge construction. Future bridges may feature smart monitoring systems to detect issues early, optimize traffic flow, and enhance efficiency. Can you imagine driving from China to Europe one day? While it sounds like science fiction, advances in technology may turn transoceanic or transcontinental bridges into reality. Each bridge is a dialogue between humanity and nature. China's bridges are not just feats of engineering, they symbolize the intelligence and determination of the Chinese people. When you stand on these bridges, they connect more than just two shores, they connect us to the future. Chinese bridges are telling the world, China doesn't just build bridges, it uses them to connect the entire world. China is the land of bridges, the birthplace of countless iconic structures. As Mr. Mishing once said, bridges are a reflection of a nation's culture. Today, China's bridge construction capabilities rank among the world's best, with an average of 20,000 new bridges built each year. These achievements are significant not only in terms of technological innovation and engineering expertise but also in driving regional economic growth. China's bridges, proudly made in China, are a testament to its engineering prowess, inspiring awe and excitement. Advances in new structures, materials, equipment, and technologies, especially their application in long-span bridges, have propelled China's bridge-building capabilities to world-leading levels. Notably, numerous long-span, heavy-load, and high-speed bridges have been completed, greatly enhancing China's status in global bridge construction history. According to incomplete statistics, 6 of the world's top 10 longest-span suspension bridges are located in China. Among them, the Wolfing Mountain Yangtze River Bridge stands as a milestone, a kilometer-scale dual-use suspension bridge for both rail and road traffic. Its completion marks China's pioneering use of suspension bridge designs in high-speed railway construction, solidifying the nation's leading position in large-span bridge building technology. The Wolfing Mountain Yangtze River Bridge, as the world's first high-speed railway suspension bridge, sets an example for future projects. The Chinese standards it established are undeniably of global significance. It has brought China's high-speed rail into the suspension bridge era. More importantly, it ensures that the name of China is the first to appear in the records of high-speed railway suspension bridges worldwide. The world remains the same, but China is no longer the same. China, with the infrastructure powerhouse taking on the heavy responsibility and historical mission, will continue to push forward, innovate, and drive China's giant ship steadily toward a promising future. China is a nation of resilience and determination. Its hard-working people embody the essence of perseverance and dedication. Despite facing numerous challenges and enduring profound pain, they never cease to strive for greatness. China's indomitable spirit is a testament to its unwavering commitment to excellence. In times of adversity, China's deep understanding of humanity shines bright. Their profound philosophical insights encapsulate the essence of compassion, empathy, and unity. China's philosophy of life is a boundless source of wisdom, guiding individuals toward a deeper understanding of the human experience. With its rich history and cultural heritage, China has left an indelible mark on the world. The achievements of its people and their relentless pursuit of progress inspire admiration and awe. Their unwavering determination to make China the best resonates with the hearts of millions. China's contributions to humanity are truly remarkable. From revolutionary advancements in technology and science to promoting peace and harmony in a rapidly changing world, China has proven to be a guiding light for humankind. Let us celebrate China, a nation that continues to grow and prosper against all odds. Let us cherish its commitment to humanity and tireless efforts to uplift both the nation and the world. China's unwavering spirit and deep understanding of humanity elevate it to a position of admiration and respect. May China continue to shine bright, leading the way toward a better and more compassionate future for all. The journey through China's megaprojects is one of awe and inspiration, a testament to human ingenuity, innovation, and the relentless pursuit of progress. Each of China's major projects showcases the remarkable feats that can be achieved when vision, technology, and sheer determination come together. If you found this video insightful, give it a thumbs up and share it with others. We would love to hear your thoughts and insights in the comments section below. Don't forget to like this video and subscribe to our channel to stay updated with more fascinating content. Thank you for watching, and we look forward to seeing you in the next video. Let's continue to explore, learn, and inspire together. Take care and goodbye.